So here we are in the last section that is on our exam next Thursday. 5.4 log. This is the last one. It's the biggest, one of the biggest sections in the course. So logarithms. So logs are written like this. Log, maybe base 3 of 9 equals 2. There's a logarithm statement, just to get us started. So did you hear the way I read that? Log base 3. That's why that 3 is lower down. When we say base, we mean bottom. Like over here, these are called baseboards, aren't they? Because they're on the bottom. This is the base of the table, right? Because it's the bottom. So when we say log base 3, we just mean that's the bottom. Now, let's stop right here. You guys have had logarithms, right, in algebra, and you know all about them. No, I'm just kidding. We're assuming, we're starting from the ground floor. But you have had them. So what if I was to ask you straight out, or what if somebody on the street was just to stop you, say, you're in one of them math, science, college classes. What is a logarithm? Like, what is the thing? I would have had no idea how to answer that. When I was in your seat taking pre-calc and calc and stuff in junior college, and somebody asked me that, I would have been dumbfounded. Like, yeah, good question. Like, what is it? Yeah. I said, I could do them. Give me some problems. I can crank them out. But like, what is it? Like, physically, is it? Yeah, I've got no idea. It's weird. It's weird I'm doing stuff and I don't even know what it is. Same thing with sine and cosine and tangent. Somebody's asked me at that point, do you know what those are? I don't know if you know that. We'll talk about that in a month and a half. But, and you've had trig, right? But if somebody was to ask you straight out, so you did all that, what's a cosine? I mean, where is it? I don't see one. What is it? Like, what is it in the real world? I wouldn't have known. We'll talk about, maybe you know, maybe you don't. We'll talk about it in a month and a half. But today, logarithm. What is a logarithm? Does anybody know? What is a logarithm?
It's that one thing with the stuff.
Yeah, what's it for? I mean, why do we do it? Did they just make it up? The answer is always yes to that.
Yeah.
Yes, they made it up. Why did they make it up? You know what it is? It's the inverse function of exponentials. That's why we have these sections back to back. Exponentials 5.3, logarithms 5.4. They are inverse exponentials. That's why, you see, they had real life situations in which they needed to solve exponential equations. And so they made up something that would undo an exponential, his opposite, his inverse, which is a logarithm. That's what it is. Think about it. If you needed to solve, you guys already know this, if you needed to solve something like square root of x equals, I don't know, 3, you would know how to get that root off of that x and make it into a normal x, wouldn't you? What would you do to get that root off that x? You would, and you got to do both sides, right? You know, and what would happen here? These would cancel because they are opposites, inverses. That's what you're doing there. And that'd be 9. Or, vice versa, what if somebody gave you x squared is 49, and you wanted to get that 2 off of there and solve that thing? What would you do to get that 2 off there? Root it, because again, roots and 2 powers are opposites. And they cancel each other out, and they get rid of each other. Well, that's what logs are. If you have an equation like 3 to the x is 10 or whatever, and you need to get that x out of there, you know what does it? Logarithms. They get x's out of the power zone and solve them. All kinds of real life things. We'll see it next week or for sure the week after. Financial, especially financial. We'll also see science like in a petri dish, you know, E. coli growing in a petri dish, or rabbits out in the field. We'll see exponential real life situations, and we'll come down to the equation. We need to solve it. You know what'll do it? Logarithms, because they undo exponentials. So logarithms were made up as the inverse functions of exponentials. That's what they are, which I had no clue of when I was in your seats. All right, so I'm going to use that thought to drive us all the way through 5.4. So what they're going to ask us to do for starters here in the very beginning of the section, just kind of a warm-up, they're going to say, hey, just go between the two worlds for a few minutes. So that'd be like me going between English and Spanish. 1, uno. Dos, 2. Back and forth, right? I'm saying the same number. I'm just saying it in 2 different languages. So I'm saying a statement in logs here. That's a log statement. How do you say that in normal, non-log talk? Well, you got to get rid of that log word. So I got to do the opposite to it. It's kind of like having a root in there, and I want to get rid of that root. I'm going to do the opposite, right? So I got a log in there. I'm going to do the opposite. Now, what have we been talking about? What's the opposite of logs? Powers, exponentials. So what? And now the bases must match, right? This if I go 3 to the x is 10 or whatever, what's the base there? 3. So when I do this logarithm, what's the base? 3. So whatever's low down, whatever has something on him, for both powers and logs, that's the base. So if you bring in the same base for a log and a power, they cancel. So what's the base of this log? 3. So what am I going to do? 3, 3. As I bring in a base of 3 to both sides. And what happens? Bye-bye. 9 equals 3 squared, which we already knew. What a simple statement. And the log is saying, that's what I was saying all along in my weird little log language. Do you see that? 9 equals 3 squared is the same thing as log base 3 of 9 is 2. That's just saying it in log. That's saying it in powers.
So when you're putting that 3 right there, you're saying
I'm
exponenting?
Yeah, powering. Yeah, I'm bringing 3 in as a base for both these guys to be powers.
Okay.
Yeah, that's right. Good observation, Rebecca. Yeah, this is the base, and this all is his power. And this is the base, and that 2 is his power. Yeah, so it's not, yeah, everybody see that? Rebecca's question's a good one. That 3 is not just sitting here next to him. Then he wouldn't be a base. Right? Right? Look over here. This board right here, that's not a baseboard. Why? Because he's not on the ground. He's just a board. But the one on the ground's a baseboard. Right? So we're bringing in a base. Rebecca's point's a very good one, and I see people mess it up a lot. So really good that we highlight it right here at the beginning. Yeah, this 3 is lower down than that whole log. He's the base. And this 3 is the base, lower down than the 2. He's the base. So that's what makes it cancel. See how the bases match. This is a base, this is a base. They cancel. Yeah, so these guys are saying the same thing in 2 different languages. We are much more comfortable with this language, aren't we? So those are the 2 languages, log and exponential. Another way you could think of log, if you want another, probably might give too much information, but people usually like this. Power needed. That's another way you could think of the log word. That's what it really says. Instead of power, it reverses it and says power needed. Power needed on a 3 to become 9. Well, 2, yeah? That's what he's saying. Power needed on a 3 to become 9. See? Same truth. Try another one. What if I gave you log base, I don't know.
Log base something.
Try that one. Change that one now. Change it to
2 to the 4th.
exponential. So we have these 2 languages, log and exponential. So that one's obviously log. Change it to exponential. Same truth in exponential. So what am I going to do? I'm going to bring in the same base, 2. That's the base. It's lower down. These cancel. 16 is 2 to the 4th. Same truth. Different language. That good? And now we can go the other way. Let me show you the other way. Here's question 1. So 6 to the 4 is 8 squared. So question number 1 starts with the exponential like this. See, I started with log. These 2 examples, I started you with log and went to exponential. Now they're going to start with exponential, and they're going to say, change that, please, to log. Can you make that into a log truth? So what are you going to do? You're going to bring in a log on both sides. See, you always bring in, just like with the square root and the x squared. If you got square root, you square. If you got x squared, you root. You bring the other guy in, right? Because they undo each other. That's how inverse functions work in math. Getting that idea? That's more and more in higher math. Inverse functions are brought in. You have something, you bring his inverse in, and that cancels it. So I'm going to bring the inverse in now. It's going to be a log on both sides, because that's the inverse of powers. But what base? Every log has a base. There's no such thing as a log without a base. Every log has a base. Yeah, the base is 8 here, isn't it? So base 8 on both sides, right? of 64
Equals 2.
is 8 squared. Good so far? I just simply wrote log base 8 on both sides. Right? On it? Rachel?
This is just a thought. If it just says log and they don't have a number, doesn't that mean just log of 10?
Yeah, we'll get to that. You're right. All right, and then these cancel out, don't they? See, when the base matches the base, right? This is a base. Why is he a base? He has a power on him. So he's a base. And this is a base. Why is he a base? He's lower down. Right? Both of these guys have things higher than them, on them, don't they? They're both bases. When the bases match, they cancel. That's 2. Log base 8 of 64 is 2. That's the same truth this was saying. Or you can do my power needed thing. Power needed on an 8 to become 64. Yeah, it's 2.
It's
true.
What's the difference between log and natural log?
The natural log is just log base e.
Base E?
7.5 equals 2 to the x. Yeah, we'll get to that. So let's try another one. 7.5 is 2 to the x. Change to log. So try that one. Change it to log. So bring in a log on both sides. Make sure the bases match, and then they'll cancel. So what's the base? 2. Log base 2 on both sides. So this is 7.5. This is 2 to the x. So these guys cancel, don't they? X is log base 2 of 7.5. That's saying the same truth. Different language.
Can't you solve for x though?
We just did.
Oh.
X is alone, right?
Yeah.
We good? Okay, so log base 4 of 1. Now, notice there's no right side this time. They're not giving me anything over there on the right side. So just call it x. You got to have a right side. So just call it x, and now let's solve the problem. So how am I going to solve this problem? I need to get out of the log language, don't I? Because I don't speak log naturally. So how am I going to get out of the log language? What's going to get rid of that log? Powers are the opposites of logs, right? So I'm going to do base 4 both sides. That 4 is lower down. He's a base. These cancel. 1 is 4 to the x. What's that? So I get rid of the log by doing the same base. Right? And so now, can you solve this by observation?
Yeah.
4 to what power is 1?
0.
X has got to be 0. That's the answer. So you see, that's how we're going to solve logs. We're going to get them out of there by doing the same base on both sides. By doing the inverse function. So I just did base of 4 on both sides. Is that good? Let's try one more. All right, let's finish with that one. So start by going equals x, right? Because the right side's missing, so just call it x. And then get rid of that log word. Get that log out of there by powering both sides, huh? So what power am I going to do on both sides? Or what base, I mean? 1. You always make the bases match, right? These cancel. So 27 is 1/3 to the x. Now that's not easy. We good to there so far? So see what I did? I just 1/3 based. I based both sides 1/3. Canceled the log out. Now, what power on a 1/3 makes it 27? Anybody know? What is it? I haven't heard the right answer yet. So what if it was just 3? 3 to what power is 27? How about that? Be 3, right? 3 times 3 is 9 times 3 is 27. Be 3. So what can make this flip and become a 3? Negative 3. Right? Negative flips it, and then third power makes it 27. All right, so more of that Thursday. Thursday's a big day. Come in well rested and ready to go.